I start with the toy pose. Here we have given 4 sentences and in our solution we have made them into lowercase for confidence. Here the 4 sentences. So next after that first question I construct a vocabulary table corpus so that I will build a table when shows all unique words in courses. So table is like this and the total number of words in the vocabulary comes around 50. For part B the question is hot vectors. Here is the hot vectors. Hot vectors of the word mission systems and users. So here the hot vector uh, is a list number of 1 with 1 and only other values set to 0. So the 1 present at the word index which was mentioned in the table before. So the missions, if we observe, the missions index is 2. So is the reason here this is we have kept 2 we kept 1 index 2 and the rest all is 0. So same follows with the system C use of part C. The question is to complete Euclidean distance here. Euclidean distance for the given distance given page. So first Euclidean distance is 2 and the dimensional vectors vector distances. So it can be defined as the formula for missions and systems. We have observed these vectors. These vectors of them, when we return them, besides we can calculate the difference vectors 0 minus 0, 0, 1 minus 0, 1 and so on. So here 0 minus 1 is a minus 1. So when we calculate the sum of differences, we can get final answer is 2. So some follows with the page, any page like system users, you so you calculate the cosine similarity. The cosine similarity is vision and systems. Actually, quotient cosine similarity measures the quotient of the angle theta between two non-zero vectors. And non-zero vectors is a sense of any value should not be equal to 0. So, formula will calculate first dot product and two non-zero vectors and then individuals. Magnitudes which multiply each other then first for the pair missions. So, system dot present given like this because you can see when we have written two vectors besides, can we that say 0 into 0, 0, 1 into 0, 0 so we can get 0 at everything. So the dot product becomes, the magnitude becomes, and one only position is less of 1. 0 will calculate cosines. Here 0 will calculate cosines 1 because only position if one rest or odd. 0 when we calculate cosine similarity, missions and systems will get 0. And the same calls which pairs and users. The question D is that how we can prove that Euclidean distance to and cosine similarity is 0. So this is we can say that you have taken EI is for words which words we can take Wi and Wj to be one hot vectors and Ei is having one at position I and Ez having one at position z. When we calculate the Euclidean distance here we have one position Ei having one position at I and Ez having one position at z. So when we calculate the Euclidean distance we can know that the position k is equal to I and the answer will always be 1 and the position k is equal to z and the will always be minus 1 square and that is 1. All other positions because value of k is 0 and overall distance will be 0. Hence, Euclidean distance will always conclude the 2. The next cosine similarity same process when ei is a non-zero 0 position if we uh, cannot be 0 simultaneously. So every dot product would become 0. Hence magnitudes are not mandatory because the 0 anything would be 0. Hence cos similarity would be 0. Next we move to the fifth question where here they asked a realistic vocabulary of 50 words here and 30 million vocabulary. How much memory could be taken for one hot encoder? So, a one hot encoder good vocabulary size V and needs V square entries. V needs V square entries. Hence, 50,000 words would be required 50,000 squares and this is 4 bytes is that each and entry is floor 32 that is 4 bytes. So 15,000 words, it will be total 9.3132 GB. And for 13 million vocabulary, the total word will be 614.7170 terabytes. So if we want to scale the even modest vocabulary 50k words, storing the full one format requires 9.3 GB, which is already impractical, like Google companies, and this is realistic large case. Mob 15,000 13 million words. The matrix would require 600 terabytes, which is entirely infeasible to store or compute intense matrices in a single matrix. So